First lesson looking at probability problems. A little bit of background here, hopefully familiar. Firstly, there's the idea of the complement, which is something we say to people when they're looking nice, but in the case of stats, case of probability, the complement is the other part that makes up the whole, a little bit like the yin and yang symbol if you can picture it. The notation is A. For those who've done a bit of differentiation, it looks like a derivative symbol. And so the probability of A complement, this line here, looks pretty fancy, but the probability of the complement of A happening is 1 minus the probability of A happening. Now, that might be a way of making it look complicated. So e.g. the prob A drawing a diamond from a pack of 52. The probability of A drawing a diamond is 13 out of 52. So if we're working out the probability of drawing a card that's not a diamond, we just take that away from 1. So 13 out of 52, or it's a quarter of the pack. So we go 1 minus. So that the complement is good. You need to know the definition, but we use it to save time. And so this hospital one depended on 2 generators, can't be in the city, generator A and B, and neither of them run all the time. And so what is the probability that at least one is running? Well, there's a few things that can be going on. There's 4 different things that can happen. And if A means it's running and A dash means it's not, or A complement, there's 4 different things. But we want to know the probability of all 3 of those together. That both are running, or A is running, B is not, B is running, A is not. And so, rather than work the probability of all 3 of those things out, we can just work out the probability of one of those things. That's where neither A nor B are running. And so we can go 1 minus the probability that neither runs. A little bit of notation, that means the complement of A and the complement of B. So neither are running. The way we work that out, whenever you see the word and, we usually use this. So 0.1 is the probability that A is not running. 0.05 is the probability that B is not running. The chance of that and that, we times, and we get that. So 1 minus 0.005 is 0.995. Now, that's one tip. And the second one that's covered on the first page is this. Is the idea of writing it out first. I struggle to get this across to people. People want to dive in and hack at the problem before doing this. But this is a strong recommendation from me, for all that's worth. This is a very basically written question. No imagination used here at all. A bag contains 8 balls. 3 of them, I might put a comma in there, I don't know, might be good. 3 are blue and 5 are red. 3 balls are drawn without a replacement. What is the probability exactly 1 is red? Now, what I recommend you do is before you worry about any numbers or fractions or probabilities, simply list the things that would satisfy that. And so, exactly 1 is red. This would do. A red one, then 2 blue. Order kind of matters here. So a blue one, then a red one, then it must be the last one is a blue. Or a couple of blues first, and then a red. And then after we've done that, and if I highlight this might work, we can then bother with the probabilities. And another way of writing it is probability R, B, B, and so on. So P with something in the bracket, just the probability of what's in the bracket happening. Remember, an and leads to a times, and or leads to a plus as a rule. So this one is, the first one is red, the second one is blue, and the third one is blue. And so we got a plus, or that option, or that option. You notice that the bottom line is going down because firstly we're selecting from 8 balls, 5 of which are red. Then 1 ball is gone and it's not replaced. So now we're choosing out of 7 and there's 3 blue. And then if 1 blue and 1 red are gone, we're left with 6 balls in total, and 2 of those are blue. Now, actually in this case, all 3 of those tend to be the same thing. So that is the same as all of that, is the same as all of that. So we could just go 3 times the first one. Yeah, unashamedly use a calculator, and there we get the answer. Now, so there's 2 main tips. Use the complement to save yourself time, and remember what it means. It's the rest that makes up to the whole or to the one. And 2, if you get a complicated problem where there's more than one option, before you pull the trigger on the actual values, be prepared in some form or other to write it out, lay out all the possibilities, and then worry about the probabilities for each of those possibilities. Okay? I hope that helps.